quadratic formula is derived by completing the square. Let's say the general quadratic ax squared plus bx plus c equals 0. And I'm going to just impose that a is not equal to 0. Because if a is 0, then you have a linear equation. So there's no point considering a equals 0. First step, you divide both sides by a. This way, the coefficient of the x squared is 1. So we can do what we did before. Comparing x squared. So you compare this to another change variable, x plus c squared minus c squared equals x squared plus cx. If you compare this to this, you will see that c is, sorry, it's 2c. 2cx, 2c is equal to b on a. So c is equal to b divided by 2a. So x squared plus b on ax is equal to, this is 2c, this c is equal to this. If I rewrite this in that form, we get x plus b on 2a squared. But now we need to subtract c squared. So we're going to subtract b on 2a squared. If I square the top, it's going to give b squared. If I square the bottom, it's going to be 4a squared. So we've written these first two terms in that form. That becomes this. X plus b on 2a squared minus b squared on 4a squared plus c on a equals 0. So now again, we have a perfect square bracket and a whole bunch of other constants that we can deal with later. So let's move everything over to the other side. X plus b on 2a squared is equal to b squared on 4a squared. Move that term across. Move this term across. C on a. This isn't looking very neat because these aren't the same denominator. So we're going to rewrite them as the same denominator. B squared on 4a squared. That's 4a squared. That's a. So multiply top and bottom by 4a. 4ac divided by 4a squared. That is b squared minus 4ac divided by 4a squared. Okay? So we have this. This is equal to that. So we can now just take a square root and solve for x. X plus b on 2a. So we're getting close now. We're almost there. Remember what I said before, how you can square root the top and bottom separately? Well, if we square root the bottom, we just get 2a. There's already a plus or minus sign, so we can just say it's 2a. So that we can keep the plus or minus sign, square root the top by itself, and you have 2a. Let's solve for x. So move this term across, minus b divided by 2a, a plus or minus square root of b squared minus 4ac on 2a. Because these have the same denominator, we can just combine the terms. Minus b plus or minus square root of b squared 4ac. So this is the quadratic formula. If you're given an equation in this form, you can immediately write down the answer if you remember this formula. Let's see how to use it. So, let's say you have 4x squared plus 3x minus 2 equals 0. A equals 4. B equals 3. Compare. C equals minus 2. Okay? So, using that formula immediately, x equals minus b plus or minus b squared minus 4ac. So minus b is minus 3. And now plus or minus b squared is 9. 4a is 16. So 4ac is minus 32. So we're subtracting minus 32. That's all that's divided by 2a, which is 8. That is your solution. Essentially one step. If you can remember the quadratic formula, you can solve quadratic equations in one step. However, in many scenarios, it is still very important to be able to complete the square. There are many areas of maths in which completing the square is often easier to do than directly plugging things into the quadratic formula. Because in the quadratic formula, you have to actually you have to firstly remember the formula, and you have to then plug in all these numbers individually. Whereas if you complete the square, sometimes you can see things immediately, rather than having to plug things into the quadratic formula. Here's an example. Take x squared plus 2x plus 1 equals 0. If we were to use a quadratic formula, this is what would happen. A equals 1, b equals 2, and c equals 1. So, x equals minus b, which is minus 2, plus or minus b squared, which is 2 squared, minus 4 times a times c. So that's 2 squared minus 4 divided by 2a, which is 2, equals minus 1 plus or minus square root of 0, which is minus 1. So after all that effort, you say x equals minus 1. But if you were to complete the square, you would find that 2x, this is actually equal to, so that is equal to 0. You have x plus 1 squared equals 0, x equals minus 1. If you solve it by the quadratic equation, all you see is x equals minus 1. If you solve it this way, you can see that x is equal to minus 1 only because this expression is actually a perfect square bracket. So it depends on what the question is asking. If the question is asking to solve it, then just go for this. Generally, in fact, nowadays, if I have to solve a general quadratic equation, I won't bother completing the square. I will just use the formula because I've done it many times and I know the formula. However, the formula is easy to forget. It's easy to forget that that's a 4 and not a 2 or 1. It's easy to forget that there's a minus sign. It's easy to forget there's a b is a minus there. It's easy to forget the plus or minus. And of course the fact there's a 2a on the bottom. There are many things about the formula that you can forget. So before you're completely comfortable with using that formula, I would still suggest that you complete the square. Completing the square never fails. Provided you know how to complete the square properly, you will never fail at doing it. All you need to remember is that. If you can remember that, you can complete the square on anything.